In this video, we are going to review some improper integrals. The first example is to determine whether the integral is divergent or convergent, and we find the value of the integral if it is convergent. The integral of 1 over e to the x plus e to the minus x from 0 to infinity. Now we see that the upper limit is infinite. Therefore, this is the improper integral. And to find this improper integral, all we need to do now is we are trying to find the limit, and will that be approaching to the upper limit, which is infinity. And instead of writing the infinity here, I'm just writing the value from 0 up to b, and 1 over e to the x plus e to the minus x and then dx. Now, if the limit exists, then the integral is convergent. If the limit does not exist, then the integral is divergent. And how do we find the integral of 1 over e to the x plus e to the minus x? Well, we don't see any of the basics formulas that will fit into this type of integrations. But we can do some tricks here before we apply the formula that we know. If I multiply both the top and the bottom by e to the x, so let's try that. So we still have the limit. We still have the limit as b approaching to infinity, and I just need to multiply the top by e to the x, and also the whole thing at the bottom by e to the x. If you multiply something on the top, make sure you do the same thing to the bottom part. Now let's simplify the expression and see what we get here. So on the top, I still have e to the x, and now I make the distributions. I have e to the x times e to the x, so that is e to the 2x, right? We add the x and x together, and e to the x and e to the minus x, when you multiply them together, you will get e to the 0. And now we can further simplify this one more time. And I have e to the x here, and then e to the 0 is just 1 plus e to the 2x dx. And then from this step, we can start letting u to be e to the x, and we try to apply the U substitution and see what is the simplified integral that we can get. So if I let e to the x to be u, then I can find du equal the integral, the derivative of e to the x is still e to the x and then dx. And from here, you know that you can rewrite the limit be approaching to infinity, and then I have e to the x now together with dx is du. So du on the top, I have 1 plus e to the x 2x. I can rewrite that as e to the x square or u square. Okay, and then from here, you know that 1 plus u square, we can apply the formula for the inverse tangent, right? Because if you recall, we have the basics formula for the inverse tangent. The integral of 1 over a square plus u square, and du is going to be equal to 1 over a, and then arc tangent u over a plus c. So this is the formula for the inverse tangent. In this case, your a is just number 1, and then your u is u. So I still have the limit as p approaching to infinity, and I have 1 over a, which is 1 over 1, and arctangent of u over a, which is u over 1. And then from here I can simplify the whole expression again. Make sure that before you find the limit, you need to make the substitution of u back to x. So that should be arctangent of e to the x, because u is e to the x. This limit of b here is in terms of x, not in u. So make sure before you find the limit, you need to make the substitution of u to be e to the x back. And then from here, I can find the limit now. I can find the limit. So this is the limit of b approaching to infinity, and it's go from 0 up to b. Remember, this is the interval from 0 to b. The limit is still outside. Okay? So we still keep the limit outside. And now I plug in b arctangent e to the b minus, this is still the interval, arctangent e to the 0. And then limit b approaching to infinity, and e to the 0 is 1, right? So let's simplify that one more time. E to the 0 is 1, and arctangent of 1, arctangent of 1 is just pi over 4, 45 degrees. And now finally, we can find a limit by making the substitution of b here. So I have arctangent e to the infinity minus pi over 4. Alright, so how do I find this limit here? Well, this is e to the infinity, so this is infinity, or arctangent infinity minus pi over 4. So tangent of what give me infinity? Well, tangent of pi over 2 give me infinity. So that is pi over 2, and minus pi over 4. And at the end, it will equal to pi over 4. So yes, this interval is convergent because the limit exists and it is equal to pi over 4. Okay, in the next example, we are looking at the trig functions. The interval from 0 to pi over 2 secant of theta d theta. Now I know that secant of theta is 1 over cosine. Now you need to check the limits from 0 and pi over 2. When I have cosine of 0 is just 1, so 1 over 1 is 1, that is okay. But then at pi over 2, when I plug in here, secant of pi over 2 is 1 over cosine pi over 2. But then cosine pi over 2 is 0, so 1 divided by 0 is undefined. So you will have a problem with the upper limit because that is cosine of pi over 2 and you are dividing by 0. And therefore, we need to apply the rules that we learned from the improper integral. We'll let the limit of b approaching to the upper limit because there is a problem with the upper limit. And then you find the integral from 0 to b and secant of theta and d theta. And then we know the basics rule for the integral of secant. The integral of secant is just the ln of the absolute value of secant theta plus tangent theta. This is the basics formula for the integral of secant. and then we still evaluate the answer from 0 up to b. Alright, and now I still keep the limit outside, and then I plug in b to here, so I have ln secant of b plus tangent of b, and then subtract. I plug in all the 0, ln of secant of 0 plus tangent of 0. And then from here we know tangent of 0 is just 0. Okay, and secant of 0 is 1 over cosine of 0. 1 over cosine of 0 is just 1, or we have ln of 1 for the whole thing. Okay, minus that, and we still have ln the absolute value of secant of b plus tangent of b, and then minus ln of 1. But ln of 1 is, again, that is 0, so this whole terms on the right here is 0, and we still have the limit of this term. So now we have the limit b approaching to pi over 2 of this term right here. So we still have ln secant of b plus tangent of b. And now it is time to plug in the b value here and also here. So that will give me the ln, this is the bracket outside. So this is ln of the absolute value of secant of pi over 2 plus tangent of pi over 2. And we know tangent of pi over 2, that is undefined. Tangent of pi over 2 is just infinity, right? And therefore ln of the whole thing, infinity plus anything, is just ln of infinity, and ln of infinity is just infinity. So we don't have the limit for this integrals, and therefore the answer is this integral is divergent because the limit does not exist.